So we're kind of going backwards a little bit today. We're going back to proportions. All right. And just I encourage you to think about proportions in the context of proportional relationships and how we might use those proportions in a proportional relationship, seeing making any connections you can. But we're going to kind of pause on the two variable relationships, proportional relationships, and we're going to look at these as just two ratios that we're going to be trying to find some patterns and solve. Okay, so here we go. Solving proportions. Our key concept is the idea that the cross products of proportions are equal. All right, so if we set up a proportion, one ratio equals another ratio. If this is true, then the product of D and A is going to be equal to the product of B and C. All right, so the cross products, just what it says, are always going to be equal. We can use that to help us find missing values in given proportions. All right, so that's what we're doing today. Remember, a proportion is just an equation stating that two ratios are equal. Usually those ratios are written as fractions. Here's some examples. 1/2 equals 5/10. Those are equal ratios. Okay, notice that the cross products here are the same, right? 1 times 10 is 10, 2 times 5 is 10. Here's another proportion, 3/5 equals 6/10. If we check the cross products, 3 times 10 is 30, 5 times 6 is 30. It's true again when we have equal ratios written in fraction form in a proportion, the cross products are always going to be equal. Well, we can use that concept to help us solve proportions. All right, so we're going to solve proportions using cross products. Now, this first example, you can actually do it in your head. You can be like, okay, well, we're just writing equivalent fractions. So if the bottom is multiplied by 9, the top's multiplied by 9. So 2 times 9 would be, hopefully you said, 18. So the answer there would be 18/27. All right, sorry, the answer actually would be x equals 18. But we're going to actually use cross products to solve this, and I'm going to show that work. It helps when there's problems that have decimals or just have numbers that don't work as nicely and neatly as this. All right, so what we're going to do is we're going to write that cross product. So 27 times 2, all right, is 54. And then we're going to write this cross product right here. Sometimes I call this the heart method. But we're just writing the cross products into an equivalent equation, actually. 3 times x is 3x. Now we just have to solve this one-step equation. So we're going to do our first step is to use cross products to write a new equation. Our second step is to solve this equation using inverse operations. So what we're going to do here is we see the x here. We're going to isolate that variable, get it by itself by using the opposite operation to multiplying by 3. All right, so I draw my line down. I'm going to divide by 3 on this side. And to keep that equation balanced, we have to do divide by 3 on the other side. So we get x equals 54 divided by 3 is 18. So we get the answer of 18, or x equals 18. All right, let's try another example. And here we'll have, this will be a little bit different. We're going to use our, we're going to have a decimal in here and a little bit more difficult numbers to deal with. Not too difficult because 9 still, it goes into 36 easily. And so we can just multiply this by, since this is by 4, this is by 4. But that's not what we're practicing right now. We're practicing using cross products. So first step, use cross products to make an equivalent equation. Equivalent equations are just equations that have the same solution. So we know that 32 times 36 is 115.2. All right, we know the cross product. One cross product is always equal to the other cross product in all in all proportions, and this is going to be 9 times n, which is just 9n. All right, next we're going to solve this equation by using inverse operations to isolate the variable. So 9n's divided by 9 gives us just 1n, but we have to do that to the other side to balance that equation out. And when we do that math, it gets us 12.8. All right, so we could have I guess we could have done that in our head, which times 4 is 36, so times 4 would be 12.8. All right, next one. Now this one looks like one that I might not be able to do in my head as nicely. All right, although I kind of can see that if I times that by 5, it'll work. But I'm not going to cheat here. I'm going to use the method that we're practicing, and I want you to do that in your notes as well. Just practice the method, okay? We're going to first do cross products. Got a bum. There we go. All right, we got 34t on this side, and then over here we have 340. All right. I did that in my head because I know that if I multiply by 0.5, it's like taking half. So I cut that in half in my head and got 3.4. But then I said, oh, but it's not 0.5. It's boom, boom. It's 50. So, all right. So I made that 2 decimal places over. Anyway, just a trick. I thought it was interesting. Oh, man, I'm having some lead issues. All right, now we divide by 34, divided by 34 to isolate that variable. T equals 10. And that's what I thought in the beginning, because if we divide this by 5, we get that. So we can divide this by 5 and get 10. All right, but the method is do the cross products. That new equation you get, divide by the coefficient. The coefficient is the number next to the variable. Okay, once we do that to both sides, then we isolate the variable and get what the variable equals. Boom. I hope that works well. Now, one thing that could trip you up, I don't think that process for solving proportions is that all that difficult, but one thing that can trip you up, it is in word problems when you have to actually set up a proportion. So you will have word problems like this, which you can see example 2 on 219. It says the wait time to ride a roller coaster is 20 minutes when 160 people are in line. At this rate, how long is the wait time when 220 people are in line? All right. So this is a ratio, and then you have kind of an unfinished ratio. It's asking you how long is the rate for when 220 people are in line. So see, you have the initial ratio, and then you have another ratio that is unfinished. You're missing one piece. So it's just like all these ones up here, right, where there's 2 ratios, and one of those ratios has a missing piece. So that's what we're doing. We're trying to set those up. The key is that once you set it up, the book set it up here for you. Okay, that's 20 minutes for 160 people. So how long would it be for 220 people? All right, make sure one of the key things is that the numerators have the same unit. So if this is talking about time, the length of the wait, then this has to be talking about the length of wait. Okay, of the wait. And then if this is talking about people, then this has to be talking about the people. All right, one common mistake is that you flip that second ratio over, and then it's time here and people here, and that wouldn't make sense in an equation. Now, remember in dimensional analysis, we wanted the units. Let's say we had inches. We wanted the inches to cancel out, but that was when we were doing multiplying by conversion factors. This is different, completely different, completely different. We have equal signs, and we have to make sure that these are equal fractions. Okay, we're not trying to multiply fractions and cancel things out. We're saying that these fractions or ratios are equal, And so we want them to be the same exact, talking about the same exact things on the numerators, and then the same exact things in the denominators. Okay? All right. So then once you get it set up correctly, then it's just that same cross product process, cross products, simplify here, and then divide by the coefficient to isolate the variable. All right. So last thing, I want you to write down and copy this stuff down, these kind of keys here. Hey, hon, one sec, baby. All right, I'm back. She wanted me to read her a story. Anyway, so make sure your key that the numerator's units match, the denominator's units match, because we're doing equal ratios. All right, and then try the got it. Okay, try the got it on page 219, number 2. Okay, I'm gonna try to cover up the answer. It doesn't really matter as long as you practice setting it up. But it says Alicia's class is making care packages for a local shelter. They can make 8 care packages with 240 items. How many care packages can they make with 500 food items? All right, so then you have your first, right? You have your first ratio right there, 8 to 240. And then it's saying how many care packages can you make with 500 food items, right? So that would be 8 to 240. And then we don't know how many care packages you could make from 500. Notice the top is 8 care packages, unknown care packages. They're both talking about care packages. And on the bottom, we have food items and food items. Okay, so then we would cross multiply. All right, we get 4,000 equals 240x. And then we are dividing by 240, divided by 240, x equals, and 4,000 divided by 240 is going to be 16 2/3 or 16.6 repeating. So that's how many care packages you can make with 500 pieces of food. And I guess if you wanted to be accurate, you just say you could make 16 full care packages with a couple pieces of food left over. All right, there you have it. There's our lesson. That's the first half of this lesson. We'll pick up the next half tomorrow. All right, good luck.